Hello again. This is the last part for Chapter 4 on food preparation, and we're going to be covering the principles of heating foods, which we didn't get a chance to cover in the last recording. Just as a reminder, we talked about different scalding, we talked about boiling. Those are all different temperatures and different ways that the water will look. It may look like small bubbles, it may look like large bubbles that are breaking from the surface. We're going to transition that a little bit and talk now more about different principles of heating foods. And these are types of things that we'll keep in mind as how the foods become heated while we're cooking them. The first method is conduction. And by definition, conduction is when heat is transferred from one molecule to another. So for example, if you put your pan on a stovetop, the stovetop makes the bottom of the heat of the pan hot because it conducts heat from the stovetop to the pan. Most pans and most utensils that you will use to heat come in two types of metals. Aluminum pans are very easy to heat and they heat evenly from top to the bottom, although a lot of people don't like them. They're not as thick and not as shiny. Stainless steel has an uneven heating. There could be cooler spots, which is why a lot of your really nice, expensive stainless steel pans will have a ring of copper around the bottom to help conduct heat evenly across the bottom of that pan. As a side note, water is a better conductor than air, so if you're trying to heat something up and there's not a lot of liquid, it will take a little bit longer to heat it up. The next method is called convection. And during convection, what you have is when there are currents or movements of the molecules within either water or oil or some other fat when it is heated. And those currents begin to develop within that molecule and move and allow heat to be transferred throughout the food. It's based on the principle that by forcing this circulated air currents, food will be heated and baked significantly more quickly than when just the circulation of heated air happens. So we don't have a convection oven in our kitchen, but if you've ever been to a commercial kitchen or a restaurant kitchen, they may have an oven where there's fans in the back that move air around. The purpose behind that is to move the air so that it heats more evenly. Your ovens at home don't have a fan, so when you turn them on, they'll cook, but it'll take a lot longer to cook at an even temperature and throughout the whole thing. In real life, if you're at home and you're cooking on a pan, heat moving through the food while it's sitting on the stove or you stirring it will help with that convection. The third method is radiation. And radiation is a direct transfer of energy from the energy source to the food. This could be like broiling. If you've ever had your oven on the broiling setting, nothing's actually touching those coils, but it cooks it, and actually cooks it very, very quickly. Another one is if you're ever grilling something, the flames underneath there sometimes will grill. You can also get some conduction from the grill grate itself, but you also get the radiation coming up from there. Microwave is a little bit different than strict radiation. They use an infrared frequency range in order to generate waves to cause vibrations within that food. And as those vibrations speed up, it creates heat. And it particularly targets water and fat. That's why, in my opinion, microwave food is a little bit less flavorful and dry, is because it vibrates those water and fat molecules enough to heat up the food, but it tends to dry it out on top of that. If you have a food that is not containing water or fat, it tends to not heat up very well in a microwave. As a side note, don't ever, ever, ever place metal in a microwave because it will start a fire. And also, as another side note, be careful what types of plastics that you put in there. If you've ever put something like a styrofoam cup in there, you'll notice that it melts very well in a microwave. Now, those are the 3 types of heat transfer that we will talk about. Again, we have talked about all of the things in Chapter 4, but we have some pretty significant activities to do in class to really do these hands-on.